Now I will introduce a new shape, the capsule, and it will have both linear and angular velocity, so that I can steer it like this. In the last video I rotated the wall object around its center point to demonstrate how to apply a rotation matrix to determine the wall's current orientation compared to its original position that it got when I instantiated it. But I'm planning to keep the wall object static, and I will implement this rotation mechanism to another shape instead, and that will be the capsule, which looks like this. Now, the edge of the ball was the collection of points that are in the same distance from the central point. In the case of the capsule, it's the collection of points that are in the same distance from a line segment. So to define a capsule, instead of a point and a radius, like I did in the ball class, I will need to give a line segment and a radius as arguments. The capsule class will have three methods: draw to display it on the canvas, the key control to modify the linear acceleration and the angular velocity by the user, and the reposition, where the current values of the capsule are calculated. So I go to the code and I create a class, capsule class after the ball class, here. And the constructor will take the central line segment's starting point and end point and the radius. And I also create the draw, key control and reposition methods, but I leave them empty for now. Then I go up and I create a caps array to store all the capsule objects, and in the constructor I push each one in this array. And down here I iterate through the array, calling each capsule object's three methods. I can just copy this from the walls class. And I can create a new capsule object with the radius of 30. It will be a capsule. And if I go to the canvas, I won't get any error, but to actually see something, I need to go to the draw method and I need to start drawing here. If I want to draw a capsule, I need two half circles that face towards each other and connect them with two parallel lines. Now the way of drawing an arc in JavaScript is that I need to give a start angle and the end angle. 0 degree is the direction of the 1, 0 unit vector that's parallel to the x-axis, and the drawing goes clockwise in default. The problem is that the angles that I give as arguments, they must be absolute values. I cannot say that take the direction of this line and turn by 90 degrees, and that's where you start the half circle. Instead of that, I have to give a specific value for where to start drawing. And what I could do is I could calculate the angle between this 1, 0 unit vector and the line segment's unit vector using the dot product, and then add pi per 2 to that, which is a right angle. And I could set that angle as the starting angle for drawing the half circle. So I can go here and create a new property in the capsule class called ref angle, which stands for reference angle, and its value will be the angle between the unit of the vector pointing from the central line segment start point to its end point and the horizontal line represented by the 1, 0 unit vector. What I know is that the dot product between these two will return the cosine of the angle between them, because that's how dot product works. And to create the angle value from the cosine, I can use the math.acos method. But now there is an issue. If I have the angle between two vectors that it can mean two things. They can be like this or they can be like this. The angle between them is the same. So what I need is a method that tells me the two vectors' relative position to each other, and the one that I can use in this case is the cross product of the two vectors. This is the formula for that. It can tell me if the two vectors have the same starting point, then the second vector is on the left side or on the right side of the first vector. Or here's it in other words, if you can reach the second vector from the first one faster if you go counterclockwise, then the cross product value is positive. And if you can reach the second vector from the first one faster if you go clockwise, then its value is negative. So once I know if the cross product of these two vectors is positive or negative, I can determine if their position relative to each other looks like this or looks like this. So first of all, I go to the vector class and implement this cross product. Then I go back to the capsule class and I can say that if the cross product of these two vectors is negative, then I keep the value of the reference angle, and if it's positive, then I multiply it by -1, because in that case I need the vector that's on the opposite side. Let me create a reference direction property, which will be the unit vector of the central line segment, and I can just use that instead here. And then if the cross product of this reference direction and the horizontal line is positive, then I multiply the value of the reference angle by -1. And that's how I get the reference angle. I only need to calculate it once by the instantiation of the object, just so that I can display the capsule in its original position. Later, when the angle changes, I will add it to the reference angle to change the capsule position, which means that I won't need to change the reference angle itself. And then I draw the two half circles, starting and finishing, so that I can connect them with lines parallel to the capsule central line. I'm using black again for the stroke, and I'm going to choose light green as the filling color. This here is the code, how I drew these two half circles. And if I go to the canvas, okay, something I need to change is here. The reference direction is a unit vector. It has to be. If it's not a unit vector, then I cannot use the dot product to determine the value of the cosine. So let's try again. And this is the light green capsule. And I can go down, change the attributes. Let's say 200, 300, 300, 200. And now it's turned. And now that I can put the capsule on the canvas, it's time to start moving it, for which I will need to go back up to the capsule class. There are two kinds of movements I need to implement separately, the linear one and the angular one. They both have been implemented before, the linear one for the ball class and the angular one for the wall class. And I'm going to start with the linear one because I think it's easier. I go to the reposition method of the ball class and copy these lines into the reposition method of the capsule class. I copy the up and the down cases from the key control method as well, because those two will be responsible for the linear movement. And of course I will have the acceleration and the velocity properties too. The position vector, which was the center point for the ball, will be the middle point of the central line segment of the capsule. To find the current start and end points, which I will need to draw the capsule, I need a new property that stores the length of the central line segment. I will call it length. And a unit vector that stores its current orientation, which I will call dir, meaning direction. The difference between the direction property and the reference direction is that this one will stay the same all the time, while this will keep changing once the capsule starts to rotate. And if I know the line segment's length, orientation, and its central point, then I can calculate its start and the end points. I go to one direction by half of the length and the opposite direction by half of the length, and I will end up at the start point and at the end point. And now let's see if the capsule can move up and down. And it can, which means that the linear movement seems to be working. As for the angular movement, I can start copying what I did in the wall class in the last episode. Left and right keys change the angular velocity in the key control method. The angular velocity changes the angle in the reposition method. And I will also need to create an angle and an angular velocity property. And once again, I need to find the current orientation of the capsule, because that changes together with the angle property. So I go here, and I use the same analogy that I used in the wall class. I create a rotation matrix based on the current angle. Then I find the current direction by multiplying the rotation matrix by the original reference direction. And then I get the start and the end points. And if everything works well, then the capsule should be able to rotate now. Which it kind of does, but it's not perfect. What I forgot is that in the draw method, where I'm drawing the half circle, the start and the end point changes together with the current angle. If I add that current angle to the reference angle, then the half circle will get a new position for where to start the drawing. Okay, another try. And now it's rotating and the linear movement is also working. Thing is that these two are not combined yet. What I want is that if I press the up key, then the capsule starts moving along its central line segment, or in other words, along its current direction, and not along the y-axis like it does now. What I need to change is the direction of the vector that gets a value by pressing the up or down keys here. Right now the y component is the only one that's changing, and that makes the capsule move along the y-axis only. Instead of this vector, I will need one with the magnitude of the acceleration property and the direction of the capsule. Since the direction is a unit vector, I can just say that I multiply it by the acceleration property, and if the key is released, then I set the acceleration vector to 0, 0, so that it won't affect the velocity vector. And let's take a look at the capsule now. Much better. And if I change the attributes, yeah, now it's moving the way I wanted, which is good. And the last thing is that I want to keep the wall objects static. The rotation feature that I included in the last video is not needed anymore, so I set the wall class back as it was before. So all I do is copy the wall class from the episode 10, from the time when it didn't do anything special, and I don't want it to rotate. Just let it be a wall. Capsule can rotate, that's fine. And in the next video I will make two capsules collide with each other.